Hi everyone, welcome back. In this video, we are going to understand how data flows internally through a Java stream pipeline. Java streams allow us to process collections of data in a clean and readable way. Instead of writing a manual loop, checking conditions, transforming values, and storing results step by step, we can describe the complete data processing pipeline using stream operations. Let's understand the internal flow using a simple example. Suppose we have a list of integers containing 1, 2, 3, 4, 5 and 6. Our goal is to keep only the even numbers, square them, and collect the results into a new list. The final output will contain 4, 16 and 36. Let's understand how Java processes this pipeline internally. The first step is source data. Every stream pipeline starts with a data source. In our example, the source is a list of integers. The list contains 1, 2, 3, 4, 5 and 6. A stream can also be created from other sources. For example, the source can be a set, an array, a file, or a generated sequence of values. The important point is that a stream does not own or store this data. The data remains inside the original source. The stream only provides a pipeline for processing the elements from that source. The second step is create stream. We call the stream method on the list. The code is list.stream. This creates a sequential stream pipeline from the list. Creating a stream does not make a separate copy of all the elements. It creates a view or processing pipeline connected to the source. At this stage, no filtering, mapping or sorting has happened yet. The stream pipeline has only been created. The third step is intermediate operations. Intermediate operations describe how the data should be processed. In this example, the first intermediate operation is filter. The filter condition checks whether a number is even. The condition is n modulo 2 equals 0. If the condition returns true, the element continues through the pipeline. If the condition returns false, the element is removed from further processing. So 1 is removed, 2 continues, 3 is removed, 4 continues, 5 is removed, and 6 continues. After filtering, the remaining values are 2, 4 and 6. The next intermediate operation is map. The map operation transforms each remaining element into another value. In our example, each number is multiplied by itself. 2 becomes 4, 4 becomes 16, and 6 becomes 36. The diagram also shows sorted as another intermediate operation. The sorted operation arranges the elements in their natural order. In this example, the squared values are already in ascending order, so sorting does not change the result. The most important point about intermediate operations is that they are lazy. Lazy means they do not start processing the source immediately. Calling filter, map, or sorted only builds the processing pipeline. Actual execution begins only when we add a terminal operation. The fourth step is pipeline processing. This is where the internal behavior of streams becomes important. Java does not always complete the filter operation for the entire collection and then separately complete the map operation for the entire filtered collection. Instead, operations are often fused into one pipeline. Each element can move through the required stages before Java moves to the next element. Let's follow the elements one by one. The first element is 1. The filter checks whether 1 is even. The answer is false, so 1 is rejected. Because 1 fails the filter, the map operation is never called for it. The next element is 2. 2 passes the even number filter. It then moves to the map operation. The map operation squares 2 and produces 4. The next element is 3. 3 fails the filter, so it does not reach the map operation. 4 passes the filter and becomes 16. 5 fails the filter. And 6 passes the filter and becomes 36. This element by element processing can reduce unnecessary work. For example, values rejected by filter are not passed to map. However, some operations such as sorted are stateful. A stateful operation may need to collect multiple elements before it can produce the final ordered result. The fifth step is the terminal operation. A terminal operation starts the execution of the stream pipeline. In our example, the terminal operation is collect. The code uses collect with collectors.toList. The collect operation gathers the processed elements into a result container. Once collect is called, Java begins reading elements from the source and sends them through filter, map, and any other intermediate operations. Other common terminal operations include for each, count, reduce, and find first. For each performs an action for each processed element. Count returns the number of elements. Reduce combines the elements into one result. And find first returns the first available matching element. The sixth step is the final result. After the terminal operation completes, the result is produced. In our example, the final list contains 4, 16, and 36. The original source list is still unchanged. It still contains 1, 2, 3, 4, 5, and 6. The stream pipeline processes the source elements and creates the requested result without modifying the original collection. Now let's examine the complete code. We create a variable named result. We call stream on the list. Then we use filter to keep only even numbers. Next we use map to square every remaining number. Finally we use collect to store the processed values inside a new list. Now let's understand the important stream concepts shown in the diagram. The first concept is lazy evaluation. Intermediate operations do not execute when they are declared. They execute only after a terminal operation starts the pipeline. The second concept is internal iteration. With a traditional loop, the developer controls how the collection is traversed. With streams, the stream framework controls the traversal internally. We describe what should happen, and Java manages how the elements move through the pipeline. The third concept is that a stream does not store data. It processes data from a source. The fourth concept is that a stream pipeline is normally single use. After a terminal operation completes, the same stream cannot be reused. To process the data again, we must create a new stream from the source. The fifth concept is that streams can run sequentially or in parallel. A normal stream processes the pipeline sequentially. A parallel stream may divide the work across multiple threads. However, parallel execution is not automatically faster. It is most useful for sufficiently large, independent, CPU-intensive operations where splitting the work provides a real benefit. So, the quick flow to remember is this. First, we have the source. Second, we create the stream. Third, we add lazy intermediate operations such as filter, map, and sorted. Fourth, we add a terminal operation such as collect. The terminal operation starts the execution. And finally, the pipeline produces the result. That is how data flows internally through a Java stream pipeline.